All right, we are going to get started. Welcome, everyone. Rory, if we can go to the next, the title slide, please. Good morning and good afternoon, everyone. Welcome to the webinar here on the Accurate AI Simplified. I am so happy to introduce our presenters here. So we are joined here by our strategic partner, Nvidia. And we would be covering today how we can show you a demo of RAG model layered on the Denvr Data Cloud, leveraging NVIDIA's inference AI stack. And what does this all mean to you from the business outcomes and use cases perspective? We will be going through all of those details in a short while. So I'm Vaishali Ghia. I'm the Executive Officer of the Global Ecosystem and Partnerships here at Denvr Dataworks. I'm joined here by Rory Finnegan, our Solution Architect, and then also our key presenters from NVIDIA, Griffin Lacey and Tarini Bhatnagar, who are also the Solution Architects. So let's go to the next slide. So the webinar is structured, we will start with the introduction of the key business outcomes and use cases that customers are trying to achieve with the generative AI. It is very, very important to ground ourselves in what are the productivity enhancements, capacity improvements, etc. we can achieve with generative AI before we go into the technical details of the webinar and the demo. We are then going to have NVIDIA presenters talk about the NVIDIA Inference AI stack. Rory will then talk a little bit more about the Denvr Data Cloud. We are also, as I mentioned earlier, we're going to show you a very in-depth demo of the RAG pipeline and the demo on top of Denvr Cloud running NVIDIA Inference Solutions. We will sum it up with the key takeaways and open it up for the Q&A. You are welcome to keep submitting questions through the chat window, and we will be addressing them as well. All right, next slide, please, Rory. So we all saw, with the introduction of ChatGPT in late 2023, how it accelerated the adoption of the generative AI in the enterprise space, as well as the public sector customer space. And I have been in the industry for more than 27 plus years in data center, cloud, AI, networking, and security space, and I spent good amount of time with the customers and partners, and very fortunate to have that front row seat to learn about customers' business outcomes, what they would like to achieve with the generative AI and whatnot. And the customer personas that generally I engage with include line of business buyers, builders and developers, CIOs, C-suite, CEOs, CFOs, as well as Cloud Excellence Center, and then, of course, the IT infrastructure folks. So based on all of these engagements, what I have learned is that some of the key business outcomes that enterprises and public sector customers would like to achieve are employee productivity improvement with generative AI, how they can quickly create co-pilot kind of applications to help employee onboarded quickly or generate code quickly and whatnot. And we will go into some of those details in the later part of the webinar. Customers are also looking for how they can serve their customers better and improve the customer experience, achieve higher net promoter score, and in general, greater customer satisfaction with the generative AI. We also see many C-suites struggling with how they can do an ethical AI deployments in their environment. So it is very important for us to provide those kind of solutions that helps them have adoption of generative AI in an ethical manner. How to do risk management, how to achieve some of the cybersecurity goals, as well as upskill the entire talent on how to use generative AI. So those are some of the key business outcomes that we see that our customers are looking to achieve. How we map them to the industry use case is very important before we dive deep into the solution that we offer jointly with NVIDIA. So these business outcomes that I just talked about translates into some of the key use cases, such as training as a service, inference as a service, RAG as a service, how we do AI lifecycle management to achieve those business outcomes, and then also multimodal training that includes not just the text data, but audio, video, images, etc. as well. So I hope this really helps us getting grounded in the terms of how the generative AI could be used by the customers in both private and public sector to achieve certain business outcomes and use cases. Now let's talk about what growth we have seen in terms of the generative AI adoption. Rory, next slide, please. So generative AI market is poised to explode, growing to 1.3 trillion over the next 10 years from the market size of just 40 billion in 2022. And that is according to the Bloomberg Business Intelligence Research. And today, the growth is primarily driven by the training infrastructure deployments in the near term. And then gradually, it will shift to more inference-based use cases for large language models, small language models, digital ads, specialized software and services. And as you can see, how customers are already deploying some of the chatbots and manufacturing capacity improvement, leveraging computer-aided vision, CAD/CAM kind of technology with the generative AI already. And that is more prevalent in the healthcare and pharmaceutical world, where it can help with the drug discovery, genome sequences and whatnot. In the retail and the online shopping environment with virtualized shopping assistant and tailored or customized messaging. Also, in the media and entertainment, how you can do more, how you can achieve more efficiency of running of new ideas, because these are highly data sensitive applications. So again, to summarize here in terms of, we are seeing great adoption of the generative AI for some of these use cases and business outcomes that we described. Go to the next slide. So what is Denvr Dataworks and Denvr Cloud? What do we offer? What I really like about the Denvr Cloud, me being a technical person myself growing up from engineering ranks, I just love the simplicity it offers to get started on the adoption of the GPU as a service to achieve those use cases that I mentioned earlier: training as a service, inference as a service, RAG as a service, multimodal as a service, and whatnot. We offer both on-demand and reserved instances of accelerated computing for the inferencing and training use cases. And also, we offer bare metal to run your own stack without the overhead of virtualization. It is also very important to note that you can get started in just few simple clicks, as you will see in the demo from our both Nvidia and Denvr Dataworks team. It is extremely data friendly. There are no ingress fees or egress charges for you to store your data, and it's a fully integrated stack that you can use for the turnkey AI deployment. We also offer private zone, which is Denvr Private Cloud, that can be deployed as a service and consumed in a monthly manner, or also could be deployed much closer to the customer infrastructure for data sovereignty and data privacy perspective. So I'm pretty stoked about being able to just simple click and use, get started with my usage of the GPU and achieve some of this customer business outcomes of productivity improvement, manufacturing capacity improvement, and whatnot. So with that, let me hand over to the presenters from NVIDIA to talk about the full NVIDIA AI stack, and then focusing more on the inference platform. And then Rory will discuss the components of NVIDIA AI inference platform and how he's using that to build the RAG layer demo on the Denvr Cloud, as I mentioned in the introduction. So in a nutshell, for the remainder of the session, we will be focusing on inference as a service use case that I mentioned. All right, Griffin, all yours, buddy.
Thank you, Vaishali, for the introduction, and thank you to Denvr for allowing us to participate on the webinar today. So my name is Griffin Lacey, and along with my colleague Tarini, we are solutions architects at Nvidia, and our job is to help people adopt the Nvidia platform. And when you see this fantastic demo from Rory a little bit later in the webinar, you'll notice that there's a lot of components that go into building such a pipeline for something like retrieval augmented generation with an LLM. And so we wanted to peel back the layers and describe all of the ingredients that go into building such a project. And this is really best described through what we would call the AI inference platform. And we really look at inference as a full stack problem, all the way from at the lowest level, the hardware accelerators, all the way to the top of the hierarchy, which is having enterprise quality production runtimes that are reliable and that you can get support on. And so as we navigate to the next slide, I think the best place to start in describing this platform is what most people would associate with NVIDIA, which is our GPUs, which is our hardware accelerators. And what you'll notice in this slide, which describes a few different GPUs that we have in our portfolio, is that we build a number of different accelerators, a number of different GPUs. But regardless, everything fundamentally is using CUDA, and so you can run inference on any GPU. The difference is going to be that running on something like an H100 or H200 versus something like an L4 is going to be that different GPUs do different things well. And it's important, maybe as a takeaway from this slide, to understand what your model, what your project requires, and map that to the most appropriate GPU, either if you're trying to optimize things like performance and maybe tokens per second for serving an LLM, or if you're trying to optimize things like cost. And on the next slide, if we take our, the next step up the hierarchy here, you'll notice that we have tools that we would call our inference compilers and runtime libraries that allow us to optimize models for inference. So it is not advisable that you would just take a model that you've trained, just say in PyTorch, and just run that, run its forward pass and use that as your inference model. It turns out that when you are running inference, you can make a number of different assumptions that will actually help you improve performance. And so two of the tools I wanted to mention in this space, one is TensorRT, which has been a tool that's been around for quite some time now. And the idea is that it is a compiler, it is an engine that takes a trained model, takes a graph, and it optimizes it for inference. So this could be things like optimizing for the numerical precision that you're using. So maybe you train in FP32, but then you want to run inference in 8-bit integer. And it also does things like fusing layers together or fusing kernels together so that you don't incur the overhead of having to continuously call a number of different CUDA kernels, but you can fuse them into a single kernel. That's going to save some overhead and give you improved performance for inference. And then more recently, we've released a tool called TensorRT LLM, which is taking this idea of optimizing models for inference and extending it into the LLM space. And some of the biggest important features here are support for multi-GPU and multi-node, because as we know, the L in LLM is large and these models are huge and they require often not only multiple GPUs in a server, but multiple nodes of GPUs. And then as well, we have a bunch of very thoughtful, very specific features for LLMs and transformers in particular, such as page detention, which is going to make these models more memory efficient and more computationally efficient as well. So TRT LLM would be a big recommendation for us for people who are looking to bring LLMs into production and want to make sure that they're doing it with the highest possible performance. And then on the next slide, there's another big tool I like talking about, which is Triton Inference Server. And this is an open source inference serving framework that is going to allow people not only to serve models with high performance, but to allow people to serve basically any model that you can think of across deep learning, across more traditional machine learning or statistical learning. So this could be deep learning models that you have trained in PyTorch, or this could be XGBoost models or classifiers that you've trained in scikit-learn. This supports basically any popular framework you can think of, all the way from TensorFlow to Onyx backends. It can even serve just generic Python code. This can run both on GPU and CPU. This can run in any platform, on premise, in the cloud, on Kubernetes, on virtualized GPUs. But of course, we are Nvidia and we care about performance. So one of the biggest reasons that people are using Triton Inference Server today is because it allows you to get the most performance as possible out of GPUs in production. And things like concurrent model execution are really important for achieving high throughput and low latency. So with that, we'll proceed to the next slide, and I will turn it over to my colleague, Tarini.
Thank you, Griffin. Thank you, Denvr Dataworks, for giving us an opportunity to come and speak here. So now we're going to sort of move just up the stack a bit. So, for building AI applications, enterprises have sort of two pathways to AI inference at the moment. You could sort of, go towards the do-it-yourself open source deployment sort of pathway, where you are able to run your models anywhere across data center and cloud, and you have much more control over your data as you do not have to share it externally. But with this approach, you might have to make a greater commitment to your infrastructure. You might end up spending, time writing up custom codes for your APIs, and also, spending time on maintenance and updates. On the other hand, you could opt for managed Gen AI services that are being offered these days, and these offer many advantages, such as they're very simple to use, very user friendly as well. You don't have to think that much about the infrastructure setup, but these services come with certain trade-offs, such as the infrastructure is limited to the managed environment that is provided by the services. You might have to sort of share your data and your prompts externally, which is not desirable for many industries. And overall, you have sort of a limited control over your Gen AI strategy. So this is where NIMS comes in. NIM stands for NVIDIA Inference Microservices. And basically, NIM provides models as optimized containers that you have the ability to deploy anywhere, be it on cloud, data centers, or workstations. And the goal over here is to build Gen AI models in minutes rather than weeks. So let's spend some time just looking at the anatomy of a NIM service. So on your screen, as you can see, NIM is a pre-built container that comes with a Helm chart that has been tested and validated across different infrastructures and across the Kubernetes platform as well. The good thing is that it comes with very easy to use industry standard APIs. So it is very easy for you to switch from managed Gen AI services if you wish. And you are able to run it on many different sort of infrastructure configurations. So basically you have control over both hardware and software. Over here, we have sort of done all the work for you because NIM containers come with optimized pre-built TensorRT LLM engines that Griffin just mentioned. So we provide these engine files for all the popular models on various hardware SKUs. So you are guaranteed that you will be able to get the best performance out of these models very easily. You don't have to think about, how to optimize your models, how to get the best sort of inference performance from these models. The NIM containers, we have NIM containers of different modalities like text-based LLMs or image and vision-based LLMs, NIMs for healthcare, and various other industries as well. So basically, NIM, I would say in a nutshell, is a service that provides the best of both worlds of, doing sort of a do-it-yourself strategy as well as a managed Gen AI service. So if you move on to the next slide now. How do you get started with NIMS? The easiest way for you to is to visit ai.nvidia.com, which is our platform, sort of a playground where you can play with all different models. You can experiment different models, and you have all the models from text to speech, text to image, vision models, as I mentioned before. Over here, we provide models not just from the community, such as Llama, Mistral, etc., but we also have NVIDIA models available for you to test as well. What you can do is you can easily go over there and sort of create a developer account from your email address. It's free, and with this, you get sort of 5,000 free API credits that you can use to test these models, and you also get enterprise support for 90 days. Once you go there and you choose a model, you are able to create code snippets in Python, Node, and Shell that you are easily, sort of able to integrate in your code to test out. And you also have the ability to play with different model parameters, such as, the temperature, the output length, etc. So ai.nvidia.com, very easy to remember. This is where you go to play with NIMs if that is something that you want to test out. If we go to the next slide now. So Denvr Dataworks has been such a good, partners of ours. So the NVIDIA AI sort of inference platform is being deeply integrated into Denvr Dataworks platform as well. As you can see on your screen, Denvr Dataworks supports multiple GPUs such as H100, A100, A40s, which power their virtual sort of machine configurations, but also, as Vaishali mentioned, you're able to access them as bare metal services as well. You do have the ability to bring your own NVIDIA AI enterprise license. This is something that I'll just touch upon in the next slide. In terms of inference for running Triton servers, it is as easy as pulling the official Docker image into the virtual machines to get started with that. And soon enough, Denvr is also going to provide single-click NIM applications on the Denvr Cloud console for like sort of your ease of use, just a one-click application. The last thing that I want to talk about is the NVIDIA AI enterprise. So, taking your AI sort of projects from experimentation, testing, development and deployment process to production is no easy task. This is the time where things like API stability, latency requirements, software dependencies become really important because, you are free to use all the community and open source services for your testing part of your sort of development journey. That's fine. But once you get into production, you do need that sort of enterprise support because you do not want things to be breaking while in production. Like that is not something that is desirable at all. So NVIDIA AI Enterprise sort of is an end-to-end cloud-native platform that is dedicated to make your transition from, taking your projects from pilot to production very easy for you. I would describe this as a platform that accelerates your data science pipelines and streamlines your development and deployment process of your GenAI models. There are certain key elements which stand out in this AI platform, such as security advisory, enterprise support, cluster management software, infrastructure optimization tools, and production branches. The reason I mentioned these elements are because they, I think, are very necessary to maximize your AI uptime and make sure that you lower the risk of your AI software being sort of exposed to different vulnerabilities out there. Our latest release of the AI enterprise software includes support for NIMs as well. So you will get enterprise support for NIMs once you sort of, decide to take them into production. Our goal with enterprise over here is to ensure that you have a smooth transition for your projects, when you take them from the development to your actual deployment stage. So with this, I will now let Rory show us a demo of how he uses components of the NVIDIA AI sort of inference platform to build a RAG demo on Denvr Cloud. Thank you so much, Rory. Rory, up to you now.
Great. Thanks, Srini. So I'm just going to quickly go over Denvr Cloud a little bit, just to give you some context of kind of what we're going to be showing from the web console in the demo, and then I'll jump right into the demo and we can kind of talk a little bit about what RAG is and how it might be useful to folks. So this is what the Denvr Cloud UI looks like. You can see some VMs there. Basically, it's a pretty minimal, simple environment to basically get up and running. Coming from AWS, it was actually really refreshing to be like, here's a simple environment to set up virtual machines and kind of do all the things I need to do to get my software up and running. So kind of on that note, virtual machines kind of our current kind of flagship product. They're really simple to set up. Basically, all of our virtual machines come pre-configured with NVIDIA drivers, your fabric managers, your InfiniBand drivers, all that good stuff. They also come pre-installed with the NVIDIA Docker runtime environment. So you basically just start your VM and pull down an image that runs on NVIDIA and give it the GPUs you want, and you're good to go. We also offer flexible storage options, both in terms of like adjusting the root size of your volume for your VM, but we also provide options to attach NFS storage, both for personal use and shared with coworkers and that kind of thing. They're also very simple to access. All VMs right now just get a public IP address, so it's as simple as just giving it your public SSH key and then logging in right away. And it's all done in a single page, no clicking through a bunch of menus to get to finishing setting up a VM. We also provide a REST API for doing things like looking at what bare metal services you have, restarting the servers, creating and destroying virtual machines, modifying your VPCs. By default, we just give clients one VPC, but if you wanted to, for example, partition teams, or you had your own clients you wanted to separate from each other, that's definitely something you can configure via either the web interface or automatically with the REST API. So jumping right into the reg pipeline and demo, just going to go over the large language models and kind of what we're trying to modify with this demo. So LLMs are ubiquitous at this point. ChatGPT and Copilot and these kinds of tools are being used all over the place for different tools and by different people, but they have some limitations. So one, for example, they're overly general. So if you're asking a very specific question, because they're trained on so much data, they can give kind of overly general responses when you want a specific answer. This knowledge is also static. So for example, if you're looking at an older off-the-shelf model like a Llama 2, if, for example, you want information that's up to date on the latest Nvidia hardware, it might not know this information yet. The information that you get back from it also lacks citations. So for example, if you want to figure out why it gave you a specific answer, there's no clear way of how to do that. And finally, in the worst case scenario, these are probabilistic models and they can hallucinate, which basically just means that if you give it a question, it might confidently say that, you know, the sky is orange or something, even though it's fully blue based on the weather or something. So these are all types of issues that we want to try and address in a reg pipeline. And specifically, we want to kind of narrow it down to helpful use cases for specific situations. So reg, we're just going to quickly go over this. It's retrieval augmented generation. Basically, it's LLMs with search. So the idea is that you give it your own data set that you want it to basically apply search to, and then it will still provide that nice, give it a prompt or a question, and it'll give you a response, but it will give you a response relative to your use case, and with references to the content that it's retrieved from a database. This is also useful because it avoids having to do costly retraining and fine-tuning. So you may have heard that, oh, I want to take a Llama model and then fine-tune it to my particular use case. This is an easy first step to try with smaller data sets and such, where you don't necessarily need to have to run an expensive fine-tuning job to get the results you need. So just to go over a bit of what a reg pipeline might look like. So your typical LLM would basically be that prompt there. So the prompt, for example, is what kind of network bandwidth does Denvr Dataworks offer? Typically, this would go straight into an LLM, and then you would get a response. The problem with this is, what if the LLM doesn't know anything about Denvr Dataworks? So in this case, we might want to set up a vector database, which basically takes reference documents. In our demo, this is just going to be HTML files we downloaded from Denvr's public docs. We basically run that through an embedding model and store that in a vector database that we can then search. So the prompt that we're getting is split and used in two places. The first place is run through the same embedding model to create a query vector that then queries the vector database. That returns a set of relevant context that it found. We chunk that, and we then apply those chunks to the initial prompt. This gives the LLM more context about what data it knows about and provides a more accurate response from this. So what are some business outcomes that can come from this? So the example that we're going to go over, because it's kind of personal to me, it's only been here for less than 2 months, is employee onboarding. Basically, the idea is that if you have your documentation spread across multiple PDF files and wikis and all this kind of thing, it can be overwhelming for new employees. If you could kind of embed all this information in a vector database and then have an LLM be able to query that in a reg pipeline, that might provide a more useful interaction for new employees to get up to speed with what the company offers and who to talk to about certain problems and that kind of thing. Other use cases, though, could be technical support. So let's say you have common issues that people run into. You might want to set up a kind of database full of useful information around how to solve common technical problems for your business that consumers, for example, could interact with to solve a lot of the easy problems like restarting the machine or that kind of thing. Obviously, you'd still want to have someone to help afterwards, but this could help a lot of people get started right away without having to wait for someone to answer the questions for them. And the last use case that I could think of was a personal assistant. We have lots of documentation that we get in our lives, like contracts and insurance and all these kinds of things. If you had a database, locally, for example, and secure, hopefully, and you were able to embed that in a vector database as well, then you could then have a personal assistant you could ask questions of, like, does my insurance cover leaky roof or something like this? And it would be able to go through your personal documents and see if that's coverage that you have. One thing I will note is that just because we're using reg doesn't mean that we've fully solved the issue of these are probabilistic models. The actual output that you get may be lacking specific details depending on how it identified what context was particularly relevant, but you're going to get more accurate results and you're going to have a reference of what it found rather than just using a base LLM model. So how are we going to build this for the demo? We're going to basically include two main components here. We're going to have the Nvidia NIM containers that we were just talking about, and they're going to basically serve as our LLM backend. This is useful because it allows us to get more out of the GPUs. So if you're paying for a service that has a bunch of big GPUs, you want to get the most out of them. And then for the front end, to kind of simplify things, we're going to use just a free and open source open web UI interface, which includes a built-in reg pipeline. So we basically just provided the documents we want to include in the reg pipeline. We scan those files, we incorporate them into the vector database, and then we just adjust the prompt to include that information when we ask queries. All of this will be running on Denvr Cloud, which I'll go over. Yeah. So demo time. So please stand by while I change my screen sharing, and hopefully this works.
And we see good number of questions coming in from the chat while Rory is doing his screen sharing for the demo. So feel free to submit questions through the chat window. And I know for sure Rory has sprayed the demo board this morning, so this is going to work flawless.
Yeah. No issues whatsoever. Okay, so just a thumbs up from someone on the, people can see my screen, right? Cool, okay, good. All right, so this is the Denvr Dataworks console. I'm just gonna log into my account here. Please ignore all of the passwords I have in 1Password. Right. So here's what the console looks like. We basically have two regions. There's Houston and Calgary. We're going to stick to Calgary for today. You may notice in this web interface that there are lots of links to our docs everywhere. As someone who recently was onboarded, this was very helpful whenever I got lost. So I hope we continue to keep all the links to the docs everywhere on this Buzzword web interface. Yeah, as I said, the VMs right now are kind of our flagship product, but you can also access applications. Cost usage is very important. The one plot I particularly like is the GPU utilization. So this tells you which VMs are using most of your GPUs that you've been allocated. For administration, you do have the ability to check on your VPCs. Our setup is relatively simple, but you might want to have other VPCs for partitioning teams or your own clients. And for support, we have more links to the documentation. It's the same docs, and we have a ticketing system. So you can see I opened some tickets about a month ago when I first started to sort things out. So I'm just going to run through bringing up a virtual machine because that's what we're going to be using for the demo today. So we'll hit create virtual machine. I'll type in webinar reserved. We'll do A100s. We'll do one of those, I guess. We don't need anything to persist. between restarts. We'll use just the base Ubuntu image, but this is the kind of the thing I recommend picking every single time is basically install all the default Nvidia drivers, your container runtime environment, the Fabric Manager, the InfiniBand drivers. This basically just makes your life so much easier once you get started. Just basically log into your machine, pull whatever container you want down, and you're off to the races. So you can set your root disk size. We'll stick with 500 for today. And you can set up your NFS shares. So like I said before, you basically have a personal NFS share. So for example, if you're working on multiple machines, you set up a cluster, for example, this can be used to share data sets between the nodes. I don't recommend running your models directly off of this NFS share, but yeah, this is definitely very useful for sharing data between nodes when you're setting stuff up. There's also tenant shared, which is basically if you had coworkers that you wanted to share data with, you're working on a shared project, that's where you would use that. And then the last step here is just adding a public SSH key. Use 1Password for that and hit launch. So rather than waiting for just a loading screen and then waiting another 5 to 10 minutes for me to download Docker images and whatever, we'll have a blog post where I provide a script where you can basically just run it and go get a coffee. But since we don't have that time, I'm just gonna use my dev machine here. So if you see my terminal, you should see that there's basically a Docker compose command that's been run. So this is basically 3 containers. There's a NIM container, so that's our backend LLM. This is running the Llama 3 8 billion parameter instruct model. There's OpenWebUI running, and that's going to be our front end for configuring the RAG. And then there's also a caddy server just to provide some HTTPS to kind of make things seem a little bit more professional. So I already have this running. It's already available at this URL. I've already configured the database just to save some time. I'll include instructions for everything that I'm changing in the blog post. So I have an account here. So some things that we should probably go over first is if we go to the admin panel here, and we go to settings, and we go to connections. Yeah. Basically what we've done is we've pointed the OpenWebUI container to the OpenAI API endpoint that NIM provides. This is really useful for being able to use NIM in different applications because a lot of the kind of front ends for things expect OpenAI as kind of the default right now. So yeah, so this is literally just pointing to our NIM container here. You can ignore this this password here. There's no actual authentication happening. It's just a requirement of OpenWebUI. While I'm here, I will also go to documents. So this data directory is basically where I've downloaded those HTML files. There's no processing happening that I've done. I just use wget to download HTML files from our public docs. And I'll include that command in the blog post as well. In here, you can also see that we just have a default embedding model. If you copy and paste this into Hugging Face, you'll just see what the model is. This is the default that OpenWebUI provides. But yeah, you can change that if you want. I could change nothing else here except for the RAG template. So we're going to basically have some steps for the LLM to kind of outline how to use the context for these documents. So we're going to tell it to parse contextual information. So that's the document information that it's queried for. We're going to analyze the user's query. We want to try and identify any kind of key concepts, entities, or intent behind the question in case the LLM has to go back for more information. When we determine a response, we want to try to identify cases where we can directly infer the answer from the context information to the user's question. We also want these answers to be relatively accurate and concise, and be in the same language the user gave us. This is probably the most important part of this. This is one of those important guardrails when working with LLMs, where you basically want to tell it, if it doesn't know the answer, just say it doesn't know. Don't hallucinate and give us arbitrary answers that don't make any sense. And if an answer isn't clear, it's better just go back to the end user to clarify rather than making something up. This is something that I would recommend even outside of a RAG situation to just include in your LLM model in your prompt. Again, we're saying respond in the user's language. And we're just specifying that we want a clear, concise, and informative response to the user's query, and re-emphasizing that it should adhere to the guidelines specified above. And then this is just some boilerplate for the query and the context. So I think that's everything from there. I'm just going to show the two different models I have set up. This blurred out one is the one that basically is provided by the NIM container. So OpenWeb UI basic query for models on the NIM container, I got this. And these other twos are just configurations of that. So they're all using the same base model here. So if we look at Llama, this is just to show that there's no special configuration happening here. That's just the base model. There's no changes to the parameters. There's no special prompts. It can't see any documentation. There's no vision or special capabilities or anything like this. If we go to the Yara model, yet another RAG assistant, you can see I've added a little bit of a prompt to gear it towards the use case of being a AI assistant chatbot. So the goal is for new Denvr Dataworks employees. It should have a conversational tone, informative responses, and we're going to re-emphasize that it should be using external knowledge when possible. Again, we're not doing anything special with the parameters. It's the same defaults we had with the Llama model. The only thing I've added here is it has access to those documents. So in that user directory with those HTML files, it has access to those files now. So let's, we're just going to show some questions to the base model and then some questions to the RAG model just to demonstrate what it's doing. And then we can just switch back and double check that our VM is working. But before I query this in my terminal here, I'm just going to run nvtop just to kind of prove that I'm not faking this and actually just sending like requests to an OpenAI endpoint or something. You'll see in this terminal window, there's an orange bar. That's the GPU memory. That's already loaded up because the NIM model has loaded the Llama model onto the GPU already. But you can see that there's no GPU utilization right now. But if we put a prompt into this model, which I need to select Llama, so we can see we get a spike in GPU utilization while it's processing this. And yeah, that's an expected answer I would expect from any kind of LLM that I was using. But let's say I ask it a more specific question, like what network bandwidth does Denvr Dataworks offer? Okay, so good news, bad news situation. It doesn't know anything about Denvr Dataworks, but at least it didn't make something up and think that it thought something about Denvr Dataworks, or thought it was a similar sounding company and then just gave us information around that other similar sounding company. And if we ask it other questions, it'll give us the same response. It doesn't know anything about Denvr Dataworks. So let's start up a new chat. We'll select our Yara model just to compare. So let's ask the same question. I'll just copy and paste it from the other ones. You don't have to watch me do that again. So we're asking the exact same question. So it's identified the context here. Sure, it doesn't throttle customer traffic. Yes, that's important. These numbers mostly make sense. The cluster network, yeah, 25 gigs is on the low end. Compute network, we do have InfiniBand for our nodes. And there's shared internet access for each region, that's 10 gigabit. And it makes some caveats about regional differences and cluster configurations and that kind of thing, which are all valid. Okay, let's just double check that this wasn't a fluke or that I somehow hard coded this. Let's do instance types. Okay, yeah, so I found that too. It identified that we have virtual machines with 1, 2, 4, 8 GPU instances. We do offer bare metal services. It identified the different Nvidia GPUs we offer. And the different CPU types we offer. You might want more information about it, but that's pretty accurate. So that's basically the gist of a RAG model. Hopefully that kind of clarifies how to kind of connect the pieces together. So we're just going to switch back to Denvr Cloud, and we can see that our machine is online here. I guess I can also exit this and SSH in, and hopefully that all works and I don't have weird SSH issues. Yes. And there we are, that's the SSH machine. So, okay, so I'm just going to switch back to the slides and we can wrap things up. Too many windows. All right, hopefully that's working now. Okay. So yeah, so for conclusions, everyone can see my slide for now, right? Thumbs up. Yeah, okay, good. Okay, so just to wrap up, some kind of take homes here. Just a slide about NVIDIA NIM. Basically, it's NVIDIA's way of optimizing LLMs for NVIDIA GPUs. They do have other models. I just use the LLM here. So I recommend folks check it out and see what kind of things that you can do with it. But yeah, it was a really easy way to deploy kind of an optimized LLM model in just a single container, a single command. So I recommend checking that out. That Get Started is a link to their login page if you want to set up a developer account. And we'll have the links in the blog post as well. Denvr Dataworks, basically just hopefully your take home here is that it's pretty simple to deploy AI models on Denvr Cloud. There's a link to getting started if you want to set up an account. And if you want to know more about our pricing, the pricing is also linked to our pricing page. Take home about RAG pipelines. The TLDR is their LLMs with search to help you build kind of custom tools without expensive fine-tuning jobs. There's some output from the R model when I asked it who it was. So Q&A section. I guess since I am the host, I will need to be the person.
Yeah, I will be able to read out the Q&A. Great job, Griffin, Tarini, and Rory, taking us through amazing solution of NVIDIA AI inference stack and Denvr Cloud AI stack, how we can utilize RAG to ground the AI responses in the factual data, and of course, significantly reducing the risk of AI hallucinations. In many of my customer and partner conversation, minimizing or eliminating AI hallucination is a big item. So Rory, I'm so glad you touched upon that in your demo as well. So let me read out. We have some great Q&A coming in. So let me just read out here some of the questions. So the first one was, which GPUs do NIM work on? And NIM stands for NVIDIA Inference Module. Does it also work with the CPUs or third-party GPUs?
Yeah, to add on to the answer in the chat, you know, a lot of the technology that we talked about in NIMs, right? Things like Triton, Docker, like that works anywhere, right? Any GPU, any CPU. But the core of NIMs are the TRT LLM engines. So these are the optimized inference like LLM models. And those, when you build a TRT LLM engine, you have to target it at a specific GPU because you have to know a bit about what hardware you're targeting in order to optimize certain things like, well, what is the ideal numerical precision that I need to optimize for? And you know, how much memory is available on that GPU, et cetera. So NIMs support a number of different GPUs, but which engine is selected will depend on which GPU you actually end up running on. So we have some clever way of when you actually run a NIM, it'll actually choose the appropriate engine depending on the model that you care about and the GPU that you're targeting. So it'll work on a number of different GPUs, but performance will depend on the exact TRT LLM engine that was selected.
That's great, Griffin. Thank you so much. I'm going to move to the next question, which was submitted through the chat. What other services does NVIDIA AI Enterprise support? So Tarini, maybe you want to answer that.
Sure. I would say the simple answer is like it supports everything that you need for production AI. So in NVIDIA AI Enterprise, I like to sort of broadly divide that into two sort of components in my head. One is the support for your ML ops. So things like, for infrastructure management, such as cloud native management operators, GPU operators, and, libraries for infrastructure acceleration, such as Magnum, CUDA, etc. We provide enterprise support on that. And on the other side, you have support for all of the things that you need for AI applications. So, if you take just your sort of data science pipeline, so starting from your data prep to model training to deployment, as well as the inference of it, NVIDIA AI Enterprise supports that. These are the things that sort of you can configure yourself. But if you want to sort of take one step more and get into something known as the application frameworks, we offer that as well. And application framework is basically, I would say, a package that gives you access to many reference examples that shows you how you can use NVIDIA AI frameworks in your AI product. So NVIDIA AI Enterprise basically gives you production for everything around, your pipelines that you need, starting from infrastructure to your sort of AI development libraries.
That's awesome, Tarini. Great. So the next question is, when discussing the Triton Interface Server, when discussing the Triton Inference Server, you mentioned concurrent model execution. Do you also extend this to the optimized execution across disparate GPUs and CPUs? So Griffin, do you want to take a stab at answering that as well?
Yeah. So concurrent model execution in Triton specifically refers to taking multiple copies of your model and running them within a single GPU. So this is a really important feature for performance, because oftentimes if people are serving small models, they have a large GPU, there would be a lot of wasted space there. So Triton allows you to run many copies of your model on a single GPU concurrently. But we can extend this idea further and run multiple instances or many instances of that across different devices. And so this is super important for scaling up to handle a huge amount of user requests and queries concurrently. So the short answer is concurrent model execution is for a single GPU, but you can extend this idea further in Triton with managing multiple instances of your models.
Great, awesome. All right, more questions are coming in, which I love it. So how did you get HTTPS working? Rory, that's for you.
Yeah, so basically I found two really cool tools. I'll include them in the blog post, but just to kind of summarize right now, so if I go to workspace, you'll see that I have in Vim data Caddy. So Caddy is basically a server that does automatic HTTPS and encryption for you. It basically acts like if you've used something like encrypt everywhere or something like that. Sorry, it's actually in docx. So basically all you're doing is you're basically saying, given a domain name, automatically encrypt this for me. So it basically handles the keys and the certs for you. But then I also found another tool called nip.io here, which all it does is it basically takes any public IP address and then makes it basically a subdomain of nip.io. So if I give that eventual domain to Caddy, it'll automatically encrypt and provide an HTTPS server for me. So basically that's sitting in front of my Open Web UI interface to kind of give it HTTPS connections. So
Awesome. Well, next one, can you go into more detail about how you're running the Docker containers? So maybe Rory, if you want to take a minute to answer that. And then we have one more question as well. So
yeah, so basically the best way to summarize this, I think, would be my compose file. There'll also be a config.sh in the blog post and the linked Git repo. So if folks want to run this, they basically just can run this config file and it'll install it on their machine, and they can go get a coffee while it installs some stuff. Okay, so here we have a compose file. It's a bit overwhelming, but you basically have 3 services running here. You have your NIM container service. This is the Llama model. So basically the way that NIM organizes them is that each container is its own model. So if you want to do like a Llama 3 70 billion, that would just be a different container image to pull down. We're basically mounting some data directory inside the container. And this is basically just for caching the model. So basically the first time you pull down a NIM container, it's going to also pull down the model weights for you. But if you mount this directory inside the container when it runs, it'll only pull it down the first time it runs, and every other time it'll just reuse those weights, which is really nice. There's an end file. This is basically where your NVIDIA personal access token is going to go. This is basically how it authenticates that you are you and that you have permission to pull down those container weights inside the running container. We're passing it a GPU here. We have a quick health check to make sure it's online before running the web interface. We are pointing the web UI at the NIM container on port 8000. Again, we're mounting some data so we don't have to redo everything every single time we start. Adding a GPU, adding a health check. And then we just have this caddy service as well that's just adding HTTPS connection with our config that we generate, pointing to the correct public URL. Yeah, that's kind of the high level of it, and I'll have more details in the blog post. So,
Yep, awesome. And Rory is going to create a blog, which will be posted soon, and he's also submitting some of these details and automation scripts and artifacts on GitHub too. So please feel free to check those things out in a few days. And then last question that I have is also an interesting one. Thanks for the demo. The other response showed support for 25 gigabit per second Ethernet and various InfiniBand bandwidths. Do you also support or require ROCE for the performance? And ROCE stands for converged
RDMA over converged Ethernet. Yeah, RDMA over converged Ethernet. So the 25 gigabytes per second is the tenant network traffic for essentially our A100 HGX nodes, so the 8-way 40 gigabyte or 80 gig, or sorry, just the 40 gigabyte nodes. It can also go up to 100 gigabytes per second, but again, this is just the tenant network traffic. So essentially what you use to go out towards the internet. Our InfiniBand RDMA-based traffic, it'll vary from 800 in the YYC region all the way up to 16 and 3200 in our Houston data center region. Rocky is available on some other platforms, but we're mostly just InfiniBand-based RDMA with Intel. So the only thing, there's nothing really required from your software to support that besides necessary PyTorch like distributed data parallel packages. And as Rory mentioned, that NVIDIA image will pre-install the Mellanox OFED drivers for you. So essentially you could provision 2 virtual machines within our cloud that is InfiniBand enabled, and right away you'll be able to send RDMA packets between those 2 virtual machines. And then you can take it a step further and enable tools like NCCL to be able to use InfiniBand. So it's fairly out of the box with us.
Awesome. I love this detailed Q&A. That's the highlight of the webinar, in my opinion, that shows the audience was engaged and they really got good substantial information out of this. Rory, if you don't mind just bringing up the pricing page slide, I just wanted to summarize the call to action. So we showed you here both NVIDIA NIM inference stack and the Denvr Cloud AI stack. We would love for you to get started with the test drive. It's extremely easy to do that on the Denvr Dataworks website. And again, just to quickly summarize what Denvr Dataworks offers is provide a single-click deployment of all major AI frameworks and toolsets combined with the dynamic GPU options with latest NVIDIA architectures. And also you can see the flexibility to scale compute resources up and down quickly based on immediate pay-as-you-go need or for longer-term reserved instances. And remember, we offer both virtualized as well as bare metal instances so that you have all the optionality and choice to create your own AI application. Our pricing is readily accessible, and we are really looking forward to helping our customers further with creating their AI application in partnership with Nvidia. So thank you all for being here. Recording of this webinar will be available as well on our website, and we look forward to doing future webinars together. Stay tuned for the blog post and the GitHub repositories too. Great.